quadratic expression and equation. This is your chapter number 4 of your advanced book. Okay. Now, the general form of quadratic is ax square plus bx plus c. Quadratic means an equation in which the highest power is, you can say 2. We can also say that this is an equation of degree 2. Any equation, whatever is the highest power of that equation, that is known as the degree of that equation. Like over here, what is the highest power? Highest power of the variable is 2. So what will I say? I will say, okay, this equation or this expression is an equation or an expression of degree 2. Okay. Now, right now, this is an expression. Okay. But if I will equate it with 0, or if I will equate it with anything, it will become an equation. And this thing which is written over here, this is your general form of quadratic equation. Okay, this is your general form of quadratic equation which we can solve also. Now, when we talk about this thing which is our quadratic equation, so before moving ahead, I am going to talk about the graph sketching of this thing. Okay, if you will ever draw your quadratic graph, if ever you are going to draw your quadratic graph, they are always represented by either your graph will be like this, okay, or your graph will be like this. Okay, either your graph will be like this and either it will be like this. Now, there are some points which we always have to remember about these graphs. First thing, you can see in each graph, these are the turning points. Okay, in each graph, this is the turning point because it is going upward, 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 and after that it is going downward. Over here, it is going down, 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 and after this point, now it is moving upward. So these are your turning point. Turning point over here, and this is the turning point. Turning point at this. Right? Now, for instance, I am saying, yeah, I have drawn this graph on, this is x-axis, that you remember, okay, and this is your y-axis. So see, if I will compare this one, what is happening over here, beta? Value of y is increasing, 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 increasing. And after turning point, it is value of y is decreasing, 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 decreasing till this point. So in this condition, at this point, the value of y, I'm not talking about x, because x is always in this direction, it is always increasing. As much as you are going to expand your this curve, more the more x is going to expand. So I'm not talking about x right now. I'm just talking about the value of y. Again, starting from this point, the value of y was increasing, and at this point it was the highest, and then again coming back and it is decreasing. So I can say that at this point the value of y was maximum, or I can say that it was highest value at this point, or largest value at this point, but value of y, not value of x. In the same way, if I am having this thing, so see, the value of y, I am comparing it with this one. The value of y is highest, then going down and down and down and down and down and down and reaching till this point, and then again going backward. So value of y is decreasing till I reach this point, and after that it is increasing. It means for this one, at this point, I am only talking about the turning point. I am not talking about anything else. In this curve, the turning point have got minimum value of y, or lowest value of y, or smallest value of y, whatever you want to call it. So this curve where the turning point has the maximum value of y, the turning point has got the maximum value of y, we call this curve as maximum curve. This curve where value of y value of the turning point is highest, we call it as maximum curve based on value of y at the turning point. And this curve, which is having smallest value of y at the turning point, or minimum value of y at the turning point, what will I call this curve? We will call it minimum curve. Okay, because at the turning point, value of y is the smallest one. That's why smallest one or minimum one. So because of the value of y is minimum at the turning point in this curve, so I am going to call this curve as a minimum curve. Okay. Now, about these ones, it can be expanded at any, because if I will take it like this, it can go at any point. If I will talk about this one, it can go at any point. In the same way, this can go and this can go in at any distance. So that's why I'm only considering about my turning point. Okay, because if it is a start like over here, your curve is ending over here, or your curve is ending over here, doesn't make any difference. Okay, in this way, the turning point will remain over here. Even if it is extended till infinity, it doesn't make any difference. That's why we are working on the turning point and not on the ending point of the curve. When we talk about our quadratic form or quadratic equation, basically there are few forms of factorization which we use. Like we know that we use factorization method by middle term breaking, or we use formula, or we use the concept of completing square method. Okay, completing square method is a little bit new. Now we are going to use the concept of completing square method. Okay, over here. The standard form of completing square method, which is used in ADNAS, is given like this: a x minus h whole square plus k. Okay, this thing is a little bit different, which you guys have used in exercise 1A of book 3. Okay, it's a little bit different. Now, what is the difference we have got over here, and what are these different expression are representing? This one, and this one is representing over here. Now, I'm going to talk about this thing. Okay, so first thing which I'm going to talk about is your A. This A. What does this A represent? Okay, so basically this A represents nature of curve. Nature of curve. Okay, what do you mean by nature of curve? Nature of curve means that either the curve is minimum or either the curve is maximum. This you are going to determine from value of A. Now, how you are going to determine that either it is a minimum curve or either it is a maximum curve? See, I have told you that the value of A will tell you that either you are going to have a maximum curve or either you are going to have a minimum curve. For minimum curve, if the curve is minimum, if the turning point of the curve is minimum, the value of A will be greater than 0. Means I have got an equation, I have simplified it, I have got it in this form. If the value of A is coming positive, positive 1, positive 3, positive 100, positive 1000, doesn't make any difference. If value of A is coming greater than 0, then it means the curve will, whatever the curve is given, that is a minimum curve. Okay, and if value of A is coming lesser than 0, means negative values, then the curve will be maximum. Okay, so if you will simplify your equation and you will bring it in this form, the value of A is coming lesser than 0. Lesser than 0, you will say, okay, it's a minimum curve, maximum curve, and if it is coming greater than 0, then you will call it as a minimum curve. Okay. Now, the other two variables which are given over here is h and k. H and k. But they can be replaced by anything else also. Over here, they can write anything else also. They can say, okay, like instead of writing it ax minus h whole square plus k, they can give you p and q, or they can give you r and s. Okay, anything can be given, but mostly it is h and k, so that's why I'm representing it with h and k. Okay, it's not about what is written over here, it's about its position. This position and this position. What does this represent? H and K represents coordinates of turning point. Okay, the most important point in this curve I have told you is the turning point. So H and K represents coordinates of turning point. It means this point which is the turning point, I can write it as H and K also. Or this turning point, I can write it as H and K, where H represents x-axis coordinate and K represents y-axis coordinate. Now, people get confused. Sir, like if I will say, okay, at the turning point, the value of the coordinates are 3 and 4. I'm just giving you an example. Okay, at the turning point, the coordinates are 3 and 4. So people get confused. Okay, sir, you have said that it should be H and K, but you are telling us the value of X and Y. So basically, beta, every point which is on this curve, either over here or over here, they have coordinates which will always be represented or written in the form of X and Y. But turning point is important. Turning point will tell you what kind of curve you are going to have. That's why for turning point we have got another set of representation which is H and K. So don't get confused if I'm saying the coordinate of the turning point is 3 and 4. The coordinate of the turning point is 3 and 4. So automatically you should get, okay, if sir is saying the coordinate of the turning point is 3 and 4, so it means H is 3 and K is 4. But you will get this idea further when you are going to solve our questions.